So here we want to solve for the unknown sides. So we want to use the Pythagorean relationship. So again, the Pythagorean relationship is a squared plus b squared equals c squared, which means that the square areas from the two shorter sides adds up to the square area from the longer side. So in this case here, we have a square area of 81, a square area of 16. These two square areas add up to this square area of 97. Now, since we're solving for the side length, we want to go from the square to the side length. We square root. So in this case, the side length x is going to be the square root of the area 97. And as a decimal value, this is approximately equal to, so using our calculator here, since this is not a perfect square, it works out to be approximately 9.848. So I'm going to round that to 85. Okay, so this is approximately 9.85. Now, it's important to understand that if you want to leave your answer like this is perfectly fine, because that square root indicates side length, and that's what we're solving for. Although the area shows up in our answer, because it's being square rooted, it represents side length. So this is actually a better or more exact value. So feel free to leave your answers in that form. Here we're going to find the side length of one of the shorter sides. So what we need to do is we need to subtract the area, the biggest area, we need to subtract the smaller area. So although a squared plus b squared equals c squared, our largest side is c squared. So we're going to do c squared minus one of the shorter sides to get the other side. Okay, and again, we're talking about areas here. So I'm going to do 14 squared minus 7 squared equals, well, in this case, that is going to be our x, isn't it? Okay, one of the other side length is x squared. Again, remember that these are areas that we are dealing with. We do want to find side length, so we have to square root at some point. So if I do 14 squared is 196 minus 49, that's going to give us x squared. When I subtract those, I end up with 147 is my x squared. So the square from the side length of x is going to be 147 squares. To solve this, I square root. So x works out to be square root 147. Now I don't need to use the plus minus here, although when I undo squares like this, I should really use plus minus, because this is a side length. We cannot have a negative side length. So we can just leave our answer as square root 147. Okay, so that's a perfectly good answer. If you want to give me the decimal answer ends up being what, 12.124. So I'm just going to round that to 12.12. So here the same thing. We have the x value is one of the shorter sides. So we're going to use c squared minus a squared is equal to b squared. Okay, so when we do this here, we're going to end up with the longest side squared, or the biggest square, minus one of the smaller squares. So it's going to be 10 squared is going to give us the x squared. So working this out, this is going to be 196 minus 100 equals x squared. So x squared works out to be 96 squares. So if I were to draw the square from this side, it's going to be 96 squares. Solving for x, I get square root 96. And because it is a side length, I don't need to worry about the plus minus. I'm just going to do square root 96 exactly. And if I want the decimal approximation, okay, it's about 9.797. So I'm going to round that to 9.80. Okay, so this length is approximately equal to 9.80. So this is how we apply Pythagorean theorem. The relationship is about the squares, so we have to make sure we do the squares, but often we're going to solve for side length, so we have to make sure we are able to go from square area, for example 96 squares, to a side length of 90 square root 96, or 9.8, by square rooting. So I've also left a link here for this is a link for proof without words. So if you want to use this link and just look at some of the examples of proof without words, will be useful for your poster assignment that you'll be doing in this unit.